Modeling human mobility is really important to address some very important issues, such as forecasting traffic or the spread of epidemics. However, until now, some of the fundamental principles that underlie the way we move were not really well understood. In particular, there was a paradox at the heart of the literature. Our everyday experience suggests that there are typical spatial scales in the environment that surrounds us. For example, the typical sizes of rooms, buildings, neighborhoods, and cities. And these typical scales must affect the way we move. However, many studies based on real-world trajectories have shown that there are no typical scales in human mobility, no typical travel distances. In our work, we solve this paradox. We design a new model where individuals move between places that are organized in a hierarchical structure, from rooms to buildings up to neighborhoods, cities, and countries. At each hierarchical level, places have approximately the same size and confine individual movements. Although there are some intrinsic scales in this system, when we generate synthetic trajectories using this model, we find that these trajectories are effectively scale-free. This is because when we aggregate movements occurring between different hierarchical levels, the scales present in the system are much harder to see. Now, this is exactly what happens with empirical data. So we use this model to find the hierarchical structure of places that characterize each single individual in a large-scale dataset consisting of millions of trajectories collected worldwide. For each person, we found the neighborhoods, cities, countries, and so on. We have three important findings from this study. First of all, we found that there are typical scales in human mobility, and they correspond roughly to the typical sizes of neighborhoods, cities, and regions. Secondly, we found that there are large variations across individuals, and those differences reflect differences in socio-demographic aspects, such as gender, age, and country of residence. For example, women tend to have shorter travel distances compared to men, shorter scales. Finally, we found that our model is much better than any previous model at describing and forecasting human mobility. Therefore, not only we have solved the paradox in the literature in human mobility, but also we provide a new model that can help address some real-world issues relying on the understanding of mobility, such as forecasting traffic, the spread of epidemics, and designing efficient transport.